students, tomorrow we will see these items in the class. Number one is apply templates versus XSL for each. Like in the handout you must have seen, in the first few pages of the chapter number 3, there are exercises which uses apply template syntax rather than XSL for each. Though the choice is under your discretionary thing, I would like to introduce how apply templates can be used in the place of XSL for each, or how we can write XSLT programs using apply templates also. So take a look at this small program. Well, we have a file called XML file called transcript.xml for the discussion, and the transcript XML has a root node called results, and it has got a series of transcripts. Every transcript has ID, name, and 4 courses and a level. Now I am going to write what's called XSLT to produce an output. Normally, if you see the way how we write, would be something like this. Well, it will be like this, meaning we start with the style sheet declaration and then XSL template has an open, and then it gets closed in the end of the document here down, and we have a table with the row for heading, and then this is the row that extracts the data from XML, which has to be repeated. So only for the component that has to be repeated, we use the for each here, which selects the element transcript from the results root element. So it is written here results bar transcript, and then this syntax is very simple, and as usual we have written. And then if you want to see the output, so it's called trans2.xsl. we go to here and then trans2.xsl. let us save the document, and then let us open in the browser to see the output. It produces the outputs this way, so it's fine. Now the same program we are going to alter the for each into what's called apply templates. If you see the program that on the right side of the screen, this is what is the modified one, and see how it is done using apply templates. The place where we are using for each, we use apply templates. Apply template is also similar to for each, which means it is going to apply the templates repeatedly on the selected or the matching nodes. Every time it finds a matching node, it is going to apply the templates. So much in the same way, we start with the XML declaration and XSLT declaration, then the XSL template. But here if you see, the template is closed immediately after the table's heading is over. In the table heading row, when it is over, we just write only one line called XSL apply template, which means that in this place, this template will be applied. That is the meaning XSL apply templates. So we again open XSL template. Watch here, before in the example we had only one XSL template. Here we will have 2 XSL template. The second XSL template will identify the exact node or element in which we have to apply the what's called the rule that we have written. So we have a apply template. We have a template that has to be applied here. The template says produce rows, create rows with the following data, and then this will be applied here. So exactly the missing thing from this table we will write here, so that it gets accumulated here one by one, so that you see the output. Now let us see how it works, and I take the transcript XML and I'm going to change the name. It is called APL trans apply template trans APLTRANS trans2 apply trans apply trans.xsl. Now I'm going to save this one. Let us see how the output is. I open the output in the browser Explorer, and it produces a similar output. So it's neither easy nor difficult. It is same. So whichever is easy for you, whichever you would like to follow, you can do. There is no compulsion that it has to be done this way or that way. Whereas there are certain things easy and comfortable when you follow the XSL for each. For example, if you want to change the row color, then XSL for each would be ideal to use, so that every time it changes the row, every time the row loop repeats, it can toggle the row colors. So the syntax would be written here with the XSL variable and the value for the variables. So this is all about XSL apply template. So whichever is okay with you, you can use. And number 2, class activities on page 61, 62, 63. So let us take a look at the class activities on page 61, 62, 63 here. That is end of the chapter 2. Chapter 3, 61, 62. Yes, here if you see an XML is given here, which has got electronic delivery response as its root, and it has got many sub items. And take a close observation. After examining it closely, please produce this output using the XSL. This is one exercise. You can try at home or you can try in the classroom also. And then there is one more exercise which requires you to produce a very simple output. If you look at this output here, the what is called the output prints only the students elements. So the filtering will be class bar student. And here in the above example also, something you have to note, that is total is here, which is the sum of these two. But you don't have to do sum. You can just you will have to do sum, but not by taking it individually. In XPath expressions there is a method to do it, because in the XML, if you look at exactly, there are two quantities. QTY one is here, and after that there is a QTY here. So one is the other one, the above one is 15 and this is 10. So total is going to be 25. To produce this 25 as answer, you will be writing a function like sum then bracket /QTY. This / means all the QTYs wherever it appears in the document. That is the meaning. So remember this function /QTY, sum of /QTY. So that's how we will solve this one. And also there is another exercise number 3 here, which is a very simple XML. Just reads the text data of the elements and then prints everything in a row. So you can do this also. So that is number 2. And then number 3, if you see, if you have any question, you can raise that in the forum. I can help you. And number 3, if you see, assignment 1 on XSLT. An assignment, there are totally 3 assignments to be submitted for this course in this semester, and then each one gets 5 marks. Each one is of 5 marks, and the first assignment is ready. It is uploaded in the Moodle. The question is there in the Moodle. If you look at the XML that is to be used for the assignment, it is known as book, and then it has got two sub elements, cover and the chapter. The question comes around the chapter element. So you are supposed to produce the output like this. The sequence number, this is using position you will do, and the word, this is nothing but the chapter's name, the name elements data. This is what is called as the word. And if you see the line, it is not the line number like the sequence number, but it is the attribute lines value, meaning every word when you go to every word, you come through the line attribute, line element. The line element has something called number 1 here, number 12 here, number 3. This means this word appears in the line number 1, this word appears in the line number 12, this word appears in the line number 3. That is how it is constructed. So your job is to print the word and then say in which line this word is found. So for example, the keyword abstraction, keyword polymorphism is found in the line number 1, and if you see the keyword inheritance found in the line number 12. So that is how the output is generated. So in this column you will be displaying the line number, which is the attribute of the word, attribute of the line element. The attribute name is num. Okay, and then grams. If you see grams, it is again interesting. There is something called grams, where some elements they miss this attribute grams. For example, this element line doesn't have grams, and this also doesn't have grams. And if you see the grams, it is a floating point number, but for my output I wanted it to be in a 3 decimal point. So if the number is like only 5.2, it will be displayed as 5.200. So there are few things for you to carefully deal with. And look at the color. The color is toggled. All those elements, all those name elements whose type is keyword is of purple color, and all those elements, all those name elements whose type is normal is of a different color. It can be black, red, blue, as you like. So I hope the question is clear right now. So you will be writing an XSLT where you will produce this table as output, in which you will apply these conditions and rules. There will be a few extra functions that will be helpful to accomplish this task. I can give you a demo on that also in the same video, but right now I will just show you what are they, how do we do it. So it is simple. It uses a double dot and a slash operator. A double dot refers to the parent node, which is also in the handout in the next chapter called XPath. So that's what is our next agenda also. The next agenda is XPath. So our assignment is also using some XPath functions. So look at the XPath chapter here. XPath is only to identify the elements. When you apply the XSLT commands and functions, the XPath expressions will tell you on what elements the functions are to be applied and to produce the output. So it is for traversing. You can also say traversing. Traversing means traveling through the document. So a dot simply represents the current node. A double dot represents the parent node. Slash means root, which you know already. Double slash means all descendants, meaning the suppose we write double slash and title, double slash and a name, which means all the title elements of the document, something like that. Attribute is identified by at, and star means all the child nodes. So let us see one by one how it can be useful, helpful. To know that, take an example from here. I have an XML called car, and the car XML has very few data here. It has got new car and it has got used car, and on your right you have a simple XML that just simply prints the data from used car, the model, the price and the mileage. I don't mind the year and condition. So if you want to just see the output of this one, car demo and XSL, yes, if you see the output, it produces an output like this. Well and good. Now let us try to apply these XPath functions, XPath symbols, to see how it helps us, or how does it work. Now for some reason, if you wanted to get the year elements data, which is the sub element of model, then your XPath will have here model. Then you can say that the current node's data, that is dot, but position and price and mileage, these are all going to be in problem. But just focus on only this change that I made, meaning select the car, used car and model, meaning car, used car and model, and then I wanted to print the year. So I can print here the year. Okay, I can print the year here. So whereas the position, the price, the mileage, the price is not the part of model, the mileage is not part of the model. So when you look at the output here, if you see the output here, it is producing 1 2 3, whereas it cannot say any value for price and mileage. Only the model is printed for 1999, because only this used car has this model year. Other used cars do not have model, I mean year inside the model. Hope you understand. So why all this happened? Because it happened because we are trying to specify in our XPath expression that my search should start from or apply the following things from this root, that is car, used car and model. So it goes to car, used car and model, but only in the first attempt it can see the year. Position, of course it will come always, but it will find only the year only once, but it will not find price, it will not find mileage, as price and mileage are not members of model. Only price and mileage are members of the used car. So this way, when I want to say that the price and mileage are in the previous node, the parent node. So to do that, I put a dot slash, so that it means that go to the used car and print the price, so that it moves behind one step and then prints the price. Let us see the output now. So I opened the this thing. It is fantastic now. It can read the data from the other data about the price and mileage from the root, that is called used car. These two rows are empty because the other two model elements do not have year. So don't mind, forget about this one. You are watching how we can use the dot slash, which means go to the parent node and then select the price. If you don't specify this here, it means you are trying to get a price, from inside model, but model doesn't have price. That is the point. So this is about the dot slash. And look at the attribute current and OMR. Suppose I want to say print only the details, all these details, if the price element has attributes. So I don't want to say attribute value is currency, OMR, or what attribute it has. I just want to say that it has an attribute. So I just introduce here also an attribute, price. This is mode. I will say the mode. It is maybe cash or card, like that. I have an attribute. So now to only deal with those elements of price, those price element that has an attribute, I'm going to say used car which has price, used car which has price that has attribute, that is at. But what is the attribute? I don't know. So that's why I would start. Now say the position and say the year. I cannot say the int. I delete, and I am deleting this. This is where we are going to say the current. What is the current? Current node. What is the current node that is being under filtered? So we are saving this one, and then let us run. Well, take a look at the document again here. Earlier it was not saved, now saved it, and then you see here there is a price element for which the attribute is mode. Here is a price element for which the attribute is current, and I am trying to here filter all those price elements irrespective of the name of the attribute. Wherever it has attribute, it has price element in some places with no attribute also. For example, the third car here, used car, has no attribute at all, but only these two. So I'm planning to only filter those price elements which has attributes. The other price elements without any attribute will be simply ignored. So I'm planning to only show the row number as well as the price itself. So I put current or even dot is okay. So I put current here, and let us save this one and run the program. I mean, open the output in the browser. You can see that there are two outputs, why and how. Forget about price and mileage. This is the price here. Why and how? This is because there are only two price elements in the used car which has attributes. So this is how we filter or we use this function. So these are the functions that we see in the page number 65, the XPath location operators. And then following that, if you see, there are few XPath functions or XPath expressions and its meanings. It is very easy to understand also. You also have used these things in the chapter 3, XSLT expressions. So this identifies the bookstore element, and this is the book element of all bookstore element. And if you see, this is what I said, all the descendants, meaning all the title elements, irrespective of wherever it is present, wherever they are in the whole document, wherever they are. And then this is also similar in the bookstore, wherever there is a title, and this is called @lang, which means in the double slash means wherever they are, and @lang means the attribute language lang. So select all the attributes that are named lang. So all is the double slash. So these are all very simple, and you must have used that also in the chapter number 3, or you can simply apply that in the same exercise which I have highlighted just a while ago in the car XML. This will be uploaded in the Moodle. You can find both the files, that is the XML as well as SSLT. So download and modify the functions according to the exercise, and then see the output. So XPath can deal with different kinds of data. It can deal with numeric values, strings. It can deal with the Boolean values, and it also can deal with the element nodes. So let us see. These are all some simple functions here. Look at the square bracket, and there is a little number 2 here, which says that exactly the second book element will be selected for the operation. Suppose in the exercise here, if I have given here price of 2 or used car of 2, which means that the second used car is only selected for the purpose of this transformation. So the bracket 2 and last of, it is a function, it's like a keyword which returns the last book element, and last minus 1 is penultimate, that is the last but one, last before one, like we say. If there are totally 10 books, the 9th one, this indicates the 9th one. And this is again, select all the titles which has the attribute lang. So this is again the XPath expressions that we can see. I'll just show you one example here. Suppose I wanted to only print the last used car element, so I use the word function last, and then of course it is only one, so position will be only one. And the used car, what is that you want from the used car? I want the model of that one, so I say select model. So look at the function now, look at the program here now. It is going to only apply this two from the used car, last used car. So I just run the program here, I save it here, and we can see it displays only the last car in the used car, that is Honda Accord. So what is the use of the last function? The same thing you can do if you want to just print last minus 1, so that the penultimate last before 1, last but 1. So you can see the answer is Ferrari, which is last one, and also you can just give a number 1, which means the first element, only the first element. So the output is like this: the Land Cruiser, which is the first element in the used car, not this one, the used car first element. This is new car, used car first element. So first model element. So this is how we can specify the ones. And you may also wonder how to print the first 3 elements. So this is an exercise to you. Try to find out. If you can't find out, just raise a question in the forum. I will give the hint. So the next one is about operations, mathematical operators that can be used. This is also be used in one of the exercises earlier, and the same thing is being discussed here. So which is very simple. For example, you can also add complex functions, some complex operations like this, where the price element minus 2 is more than 30. So you can select all the titles. I'm going to select all the titles of the book elements where the price minus 2 is more than 30. So this is what is interesting. So the same way you can apply different mathematical operators. If you would like to take an example, look at the transcript example that we have seen before. In the transcript XML, if you want, you can we can try to add all these 4 course values to produce the answer. So I can just add here a row which is TD, and this is going to be the sum. So what I do is I just say XSL value of select is equal to XSL value of select is equal to, let's see, select is equal to I will add all these values: COURSC1, COUR is course 1, the capital C, COUR is course 1 plus course 2, course 2 plus course 3 plus course 4. So where I have selected all the sum, this is the sum of all the courses. And let us close this XSL value of here, and now the program is good to go. We need to add one heading here. I will add the heading TD. This is called total. So let us see how the output comes: course 1, course 2, course 3, course 4. We saved it, and it is called APL trans. Fine, the data is XSL is okay, and you can see here the answer is produced where the total is fine. And if you, in some places you see the amount, the data is with multiple in exponential values. So we can use certain functions to also trim this. There is something called format minus number. The function name is format minus number, and you can try this, which will be format minus number format minus number bracket all these things, then comma of number, then comma. So what is that the format that we have to use? What is the format we will use that we can give here? We'll display the output in decimal format. If you give this character as the format string, so let us see the answer. We need to have the transcript file. So file, open transcript file. Where is the transcript file? In the desktop. And no, it's not here. This is saved in the folder 2070 after transcript, so same folder maybe, transcript XML, and then we have the transcript XML here. Let's put it here so that we can so the file is here and the SSLT is here, and let us see how it is being used. So XSL value of select format of number of course 1, course 2, course 3, and then the result. So saved, it has to be in a single quotation, so we put in a single quotation also. Now we have made an extra data here, which is to show the total. This we are seeing as an example where we can use these plus symbols and doing calculations. Thereby we are also getting an opportunity to learn the format minus number function that prints the data in a particular format. And this is the transcript file that we have. I want to make sure that they are in the same folder. This is in the folder XML 270 transcript, and this is also in the folder. Yes, so the name of the file is APL trans. So APL trans, not here. APL trans. So this one I can remove it. So I can save now. It is saved. APL trans, and then we will display this. Open the browser. You can see the answers now come in the point. It shows the decimals. So this is the function that helps to show the hash dot 00. So 2 decimal places. That's what the meaning is. And what is next? So next is about we are continuing with our XPath expressions, and so this is where we have come across, and this is again what is equal to, what is not equal to, what is greater than, and greater than equal to, less than equal to. And this is something different, or and. Suppose you want to combine two conditions either by or by and. This can be done also in the XSLT. So it all depends on the question. It all depends on the background of the scenario. Suppose we were to select books that has price which is less than 30 or 30, then this is how we will be giving the function price less than 30 or price equal to 30. So this is how. So what is the title of the book? So the question is, the final answer will be title, but those titles, if you examine, the price will be those books price will be either 30 or more than or less than 30. And here if you see, the question is a little bit different. I wanted to only display the titles of books if the price is more than 30 and the language is English. So the keyword here, the connecting word is and. So price more than equal to 30 and language is equal to English. That is, title language is equal to English. So language is an attribute, so we write at lang is equal to eng. So watch the bracket square, and how we mention the value in a single quotation. So these are all interesting exercises to do. And the star, we saw this already in the XPath beginning, how to use the star. And by looking at this, how we can understand what it is going to filter. This is all the books title or all the books price. This is select all the title and or price elements of book elements wherever book is. So you are seeing the way how we can apply several paths more than one path in the expression. That is by giving this symbol. That symbol is here not meaning and, it is not meaning or, it means and, this path and this path. So apply whatever rule is given in this path book title and in the path book price. So how we can see this? Let us see an example here. Let us take an example of match transcript, okay, and or we will take the car demo here. Let us take the car XML. It is in the desktop XML. Okay, desktop, okay, fine. Here we have a used car. Apply in the used car, and I am saying apply in the new car, new underscore car. So both I am going to apply in the used car and apply in the new car. What I want to print, I want to print the model, and I want to print the, say, price. Now this is done, and there is no sequence here, so let us change the program here a little bit, and the model and the price, there are two things only. So we just save the program, and got demo XSL, open the browser. You can see here it shows Camry, it shows Land Cruiser, Ferrari, Honda Accord, which means the new car is here, the old car number 1, 2, 3. So there are four records here, model and price. So all the model and price is here. So this is how we see, and how we can give several paths. This is how we can give several paths. This is again some numerical function. Suppose you want to get the number value of a data, you can give a number of, for example, the price. Sometimes if it is being treated as a string, then you can use the number function and then give number of price. For example, price divided by 10 by 100, multiplied by 10 by 100, multiplied by 10 divided by 100, which in this case has no issues. It will display the 10% of the price. Hope so. So it is displaying the 10%. Price into 10 divided by 100. So it displays 10%. Sometimes this price, if cannot be manipulated, cannot be processed, then we will use the number of function, so that the number of function will help us. In this case, even without number function it worked, but some cases if it doesn't work, if you think that the value is being considered as a string, and if you want to convert it as a number, then you will use number function. So there are a few more functions like this: ceiling, floor, round. This is all very simple, and the exercise, the example itself is directly showing the correct answer, and the way how it is used and the way how it works. It's very simple to understand. And coming to the string functions, string function is just taking an argument and converting it to a string, and just opposite of the number function. Look at this one, concat and string join. They are almost same. They both joins the two or more different strings. Here in this case, concat doesn't give any operator or a connecting parameter to join the strings. So whatever you give will be joined. So the example is here and the answer is here. In this case, string join, it gives a separator, how the strings are to be joined with the connector or separator. So if you give here string and an empty space or underscore or a hyphen, this is going to be joined using that separator symbol. The string length function we saw already, uppercase and lowercase as same as other languages. and the string contains, the function contains is very interesting. In the last lecture we saw a function called substring before and after. This is something that examines whether string 1 contains a string 2. So suppose you wanted to find whether the string xm is found in the first string, then you can use this contains. What could be a simple example to do that? For example, in the catalog example which we studied earlier in the classroom, if you wanted to print all those titles that contains the letter D, that contains the letter B, or contains a word THED, then you can use the the condition like this with the contains function. So it will be like catalog bar cd, then bracket square and open close. Inside you will let contains of title comma, then within single quotation THED. So this displays only those titles that contains the word D, and starts with and ends with. This is same like your substring before and after. Then substring before after we saw already in the class, and substring just produces part of the string. This also we saw. So normalized space will remove all the leading and trailing spaces, and the same thing is with the function here also. And translate function converts a string with the help of other string, meaning if you give translate string 1, 2 and 3, so this is going to find the string 2 in string 1 and then replace it with string 3. So if you see the 1230 here, 30 is discovered in this place and the replacement is 45, so answer is 1245. So converts the string 1 by replacing the characters in string 2 with the characters in string 3. So and replace is also something very interesting, but little different from translate. Here if you see here, the original string welcome is replace the E by E, so that every occurrence of small e is replaced by capital E. So this is what is replace function. So this is something when you want to print, for example, all these translate and replace, where it will be useful. Suppose you want to print a data from XML document in a particular way. All the for example, student ID is 26S1510 like that. So the S should be September. So I will write the value something like this. I will say XSL value of select is equal to what I should select. I should select simply student ID, but I will select replace of student ID comma S comma September, so that it is going to select the student ID and find the S and replace with the SCP. This is what the use. Even for translate also you can try the same example. And the aggregate functions here, it is a lot similar to other language functions, average, max, min and sum. So this is something you have seen already. Look at the date, current date and time. If you want to print current date, it is not a matter of, it is not something from XML. If you want to print the current date and time, these are the functions that you can use. So it is just a matter of knowing the name and writing the correct spelling and the cases. So that's what is all about functions. And then you have got exercises in the book and in the handout, and they are some exercises are solved, and these are all very simple examples only. And here is one question for you to write the XPath expressions. You can expect similar questions in the mid exams. After giving you an XML, you will be expected to write the XPath expression to find answers for any given description. For example, write an expression to find all English books. So all English books. So you have to examine the XML, understand that language equal to ENG means English books. So what is the way to say all English books? So all uses double slash. So the expression will be XSL template, select is equal to, now you will give the answer here, double slash, and bookstore slash book slash title, then inside a square bracket, after that inside a square bracket you will say @lang is equal to eng, @lang is equal to eng, which means you are selecting all the books, the title of the books which has language English as attribute. So similarly you can solve one by one. If you need any help, you can raise a question in the forum. I will answer you. So this is how it goes on. So we will try to do all these exercises in the classroom tomorrow. See you tomorrow.